In this video, we're going to be learning how to add a parts list and how to add ballooning. Ballooning is a very complicated subject, so we're just going to kind of go over the basics and a top-level view of it. But we're going to learn how to do this automatically using Inventor API and iLogic. So here we have a drawing with a couple views on it. But we want to add a parts list. Let's say this was an assembly. We're adding a parts list and we want to balloon. We're going to add a view of the assembly and go ahead and balloon it. This is more kind of a part drawing, but we're going to treat it like it's an assembly here. So I'll open up our parts list, iLogic rule, and kind of look at that. So we start out as we usually do in drawing automation. Grabbing the active document, setting up our transient geometry object so we can create points, grabbing our active sheet. We also get an assembly path, because in this, if we're going to make a parts list, we need to reference an assembly. So then we need to open the assembly document, not fully, not visibly, but we're going to open it and save that document for use later. Okay. Now we're going to add our parts list, and we're going to do it just simply calling sheet parts list.add. We'll pass in the assembly document. We're going to also give it a point. I'm going to go put it up in the top right corner, and so I went and found what point that was needed. And then we're going to set it as structured all levels. That will give us the parts list. Now, let's say we wanted to add a couple manual rows to that. When I say manual, I mean we're going to do it automatically, but we want to just put whatever text in we want. So I'm going to grab the row count just so I know where to add these rows. And then we'll grab we're going to make a parts list row, call it bolt row, and we're going to add, so we'll call on our parts list that we made, this is that same variable we saved, we'll call parts list rows, and we're going to add, and we'll add at the row count we want to. And this second variable is whether we want to put it before or after. So insert before, we actually want it to go after at the end. So we'll call false on that. And then we add in the values of the different cells we want. So we'll have a quantity, a part number, and a description here. And we'll do that for 2 additional rows. We're just adding 1 to our row count so it stays at the end here because we're not grabbing a new row count. And in that way, when we save and run this, we get a parts list up here. And you can see we have our 2 original parts that are actually in the assembly, and then we've added additional parts to or rows to the parts list as shown in the code.
Let me pause for a moment before we continue. If you're enjoying this course, what you're seeing here is really the starting point. We've worked with teams like Oldcastle Infrastructure to turn concepts like this into real measurable outcomes, including an 80% reduction in layout time. If you want to fast track introducing automation to your organization, reach out to us and get started at ketiv.com/automation.
Okay, now that we have a parts list, we want to create a view where we're going to have a view of the assembly and balloon it. Now this part is a bit complicated, so I'm not going to go into all the details, but we're going to go on an overview here. So I'm going to open up our ballooning rule here and kind of walk through it with you. Now this rule is going to have a couple functions. These are things that can be called inside the code and can be called multiple times even if we need to. So you'll notice at the top we have a submain. Whenever we're working with methods, functions or subs, we need to put our main code in a submain. And then we'll have these 2 functions at the bottom. One is getting all the part names from part list. So it's going to go through the part list, get all those part names that we want to balloon. the next one is to get drawing curves from a view. So we pass in a view, the occurrence we want the drawing curve from, and a part names that we're going to get before. So now kind of that you see what functions we're going to be calling here. I won't dive into the details of them, but we'll walk through kind of what we're doing here. So once again, usual suspects, grabbing the drawing document, transient geometry object, and the active sheet. We also need to get the assembly path because we're going to, once again, open up the assembly document, not visibly, to grab that document. Now, the first thing we need to do is we need a view of the assembly if we're going to balloon it. So we can add the base view here. You might have seen that in a previous video. And we're going to do that by calling OSheet drawing views dot base view. And we'll pass in that assembly document, placement point, scale. We've scaled it in half. We're going to do an ISO. So we'll put it as K ISO top right, and then hidden line removed. And that gives us our ISO assembly view. Okay, then we need to grab our parts list because we're going to grab all the names from it. So we grab sheet parts list dot item. Well, there's only one, so we're going to grab the first one. That gives us our parts list, and we're going to pass that in to getting the part names from in that function. So that'll pop out a list of strings for us. So now we need to go grab all the curves that we want to balloon. So we're going to make up a list of drawing curves called curves to balloon. And we're going to for each through every occurrence inside our component definition of that assembly document. So every occurrence of a part, we're going to loop through it. We're going to grab a curve from it. So here is where we call our get drawing view or get drawing curve from view. And so we pass in that view and we pass in an occurrence that we want to get the curve of and the part names for it to look through. That method does its thing and it's going to spit out a curve, a drawing curve here. Once we get that curve, then we just double check, hey, is the curve something? Because if it's nothing, we don't want to break, so we'll skip. But if we did get something out of that method, we're going to add that curve to our list of curves to balloon. And once we get all those curves to balloon, then we need to actually go about ballooning them. So here, we're just going to check whether our drawing BOM is defined. This is just just checking to make sure that everything's in order. So we'll pass in that assembly document full name in there. And then we're going to loop through all those curves to balloon that we made earlier. And we're going to check to make sure that we can grab a point on them that we want. Now you can do this in many different ways. This is just one way to do it, but we're going to grab that midpoint of the curve. So in this case, it needs to have a midpoint of the curve. And we're going to grab a object or create an object collection because we want to make leader points. So once we have that leader point object collection, we'll add to it and we're going to make a point and we're going to base it off of that midpoint of the curve. So we got the curve, we got the midpoint of the curve, and we're just going to put it 3 over and 3 up. It's just something arbitrary I picked. You can do it differently there. Then once we have the leader points, we also need the geometry intent of the curve. Now, a geometry intent is how we attach things to drawing curves, whether they're dimensions or in this case, balloons. And so we're going to call the method off of the sheet, create geometry intent. We'll pass in a curve, and that will give us a geometry intent object. And we'll add that to our leader points so that the leader point will attach to our actual curve there. So once that is done, we'll focus on kind of the happy path here, where we asked, is the BOM defined? That's what we'll focus on here. So if it is defined, then we'll go ahead and call draw document dot active sheet dot balloons dot add, and we'll add those leader points in right there. And that will create the balloon. And we're looping through every curve that we found in our previous methods on that curve to balloon. So we'll be adding balloons there. And so when we run that, we will get our ISO view, and we only have two parts here to balloon, but it's grabbing those curves and adding balloons. You can see that they're up to the right where their leader points is. So that is an example of how to add a parts list and balloons.